Let's look at OpenStax College Physics, Chapter 11, Problem 42. Archimedes' principle can be used to calculate the density of a fluid as well as that of a solid. Suppose a chunk of iron with a mass of 390 grams in air is found to have an apparent mass of 350.5 grams when completely submerged in an unknown liquid. What mass of fluid does the iron displace? What is the volume of iron using its density as given in a table in the book? And calculate the fluid's density and identify it. So let's write down the things that we know. We're told that the mass in air is 390 grams, so I'll call this M sub air is 390.0 grams, and the mass apparent is 350.5 grams. So mass apparent is 350.5 grams. Then that's basically all we know. In part A, we're looking for the mass of fluid that the iron displaces. We want the mass of the fluid displaced, so mass fluid displaced. In part B, we want the volume of iron, so we want volume iron. And in part C, we want the density of the fluid and what it is. All right, so here we have a diagram. We have a chunk of iron in this fluid. So the forces that act on it are, of course, the weight. So that would be M air times G. And we know that there is a buoyant force that pushes up on it. So I'm going to write that as F sub B, force buoyant. Now, from Newton's second law, we know that the sum of the forces is equal to mass times acceleration. So what this means is that since the mass of iron is not in equilibrium, this thing will sink, but not with this weight. It will just have an apparent weight. So that apparent weight then, weight apparent, will be the difference between the actual weight in air and that buoyant force. So the reason that the chunk of metal feels lighter in this fluid than it does in air is because of this buoyant force that pushes up on it. So now we're looking for the buoyant force here. And the buoyant force will be equal to M in air G minus M apparent times G. So that is 0.390 kilograms minus 0.3505 kilograms times 9.8 meters per second squared. So the buoyant force will be 0.387 newtons. Now, we can use Archimedes' principle and say that the buoyant force equals the weight of the fluid displaced. So the weight of the fluid displaced is the mass of the fluid displaced times G. And in part A, I'm looking for the mass of the fluid displaced. I'm looking for just this here. So that means that the mass of the fluid displaced will be the buoyant force divided by G, and that is 0.387 newtons divided by 9.8 meters per second squared, and we get a mass of 39.5 grams. So basically, this is the difference between these two masses that we have here. All right, now in part B, so this was A. In part B, we're looking for the volume of iron using its density. So we know that density is given by mass over volume, which means that volume is mass over density. We know the mass in air, And we can find the density in a table. And density iron is 7,800 kilograms per cubic meter. So then the volume will be 0.3900 kilograms divided by this large number, 7,800, and we end up with 5 times 10 to the negative fifth cubic meters. So this is the mass, sorry, this is the volume of iron. In part C, we want to find the fluid's density and identify it. So we go back to Archimedes' principle. So we have F sub B is weight of the fluid displaced, and that is mass of the fluid displaced times G. But we can write mass as density times volume, so that would be density of the fluid times volume displaced times G. And here I'm looking for density of the fluid. So density of the fluid is the buoyant force divided by volume displaced times G. So plugging in the numbers, we have 0.387 newtons divided by 5 times 10 to the negative fifth cubic meters times 9.8. So we end up with a density of the fluid being 789.8 kilograms per cubic meters. And if we look this up in a table, we see that it is this thing, ethyl alcohol.